Good morning once again to all of you. I hope you all are watching my videos and trying to understand the subject and the topic electrostatics. To get more clarity, you have to read and try to understand. You have to read your textbook and try to understand the concepts. You may ask me your doubts and difficulties. Today we have another topic for you. Today we are going to study about an expression for torque on a dipole placed in electric field. We have studied about electric dipole. Electric dipole is an assembly of two equal and opposite charges separated by a small distance. Now this dipole, it is placed in a uniform electric field. Now what is a uniform electric field? Uniform electric field is the field in which the lines of forces are from positive to negative charge, for example, and they are all parallel. That means the strength of electric field is constant or uniform everywhere. So it is represented by parallel lines. And now you can see here one dipole. Dipole is minus q charge placed at point A and plus q charge placed at point B. This is the plus q charge. Now it is placed at a certain angle in the electric field. Let that angle be theta. Now when it is placed in this field, the lines are showing that this side is positive and the line is going towards the negative charge. So here there is a negative charge. It will experience a force in which direction? Since this is a negative charge and this side is the positive, because of the electric field, it will have a force in this direction. This is the F1 force on the charge Q. This force is acting opposite to the direction of electric field. Now here you can see the plus q charge and here minus charge. So therefore this charge will have a force F2 in this direction, that is in the direction of electric field. Now there are two equal and opposite forces. Let us write them as F1 is equal to. Now you have studied the formula for electric field. E is equal to F upon Q naught. Now to find the force on the charge Q, we can write F1 as Q into E. Because E is equal to F by Q. So F, that is the force. Force on the charge Q, that is equal to Q into E. Since this is minus, you can write here minus also. So this is the force F1. Then similarly F2 is the force on the charge plus Q. So it is equal to Q into E. Now if you add these two charges, you can see that the net force F1 plus F2 will be equal to 0. Now this F1 plus F2 is 0. That means there is no translatory motion either in this direction or any direction, because the net force on the dipole is getting cancelled. But now you can see that the forces are acting in two different directions. For example, if I keep this scale here and apply one force in this direction and another force in this direction, then it will have an effect of rotation on the scale and till the scale becomes parallel to the field. So in the same way, a dipole experiences two equal and opposite forces on its end. And as you know that if I apply one force in this direction and another in this direction, then it will cause rotation or it will produce a torque. It will produce a couple, it is called as a couple or torque. Now torque will be acting on the dipole and it will try to align the dipole in the direction of electric field. So here the torque will act so that the dipole comes in the direction of electric field. It is because of these two forces. Now let us find the expression for torque. expression for torque on the electric dipole in uniform electric field. So you know the symbol of torque. What is the symbol of torque? It is tau. Now this tau is equal to force into perpendicular distance between forces. This is the formula which you have studied in class 11th. The torque is given by force. You can take either force because the forces are equal and opposite. So force into perpendicular distance between the line of action of force. Now this force is acting here, this force is acting here. So which is the perpendicular distance? So for that, let us draw one normal here, perpendicular. So now you can see that between these two forces, if I write this as B and this is A, this is point as C. So I have drawn one normal or perpendicular. So I can see that between these two forces, BC is the perpendicular distance between the forces. Now between F1 and F2, this is BC is the perpendicular distance. So I can write it is Q into E, that is the force, into perpendicular distance as BC. Now I want to get an expression for torque. So I have to substitute the value of BC also. So I take the length of the dipole as you already know as 2A and this angle is theta. Now you can see this is a right angled triangle. So we can apply the formula for sine theta, cos theta, tan theta, etc. or trigonometric identities. So perpendicular is BC. If this is theta, then BC and BC, side BC can be written as the hypotenuse into sine theta, or it will be equal to 2A sine theta. So Q into E into 2A sine theta, because BC is equal to 2A sine theta. I am directly writing 2A, or you can write first as AB sine theta. AB is the hypotenuse and it is the length of the dipole or distance between the two charges which we take as 2A. So it becomes the formula for torque now. Torque is equal to Q into 2A. Q into 2A, that is written as P, and this E is here. So PE sine theta. So this is the formula for torque or expression which we have derived now for torque acting on a dipole. So this formula will tell us about the different cases also. The first case is when theta is equal to 0 degree. When the theta is 0, that means there is no angle between the dipole, this is a dipole, and electric field. That means the dipole is already aligned with the field. पहले से ही उसी direction में रखा हुआ है. It is in the same direction as electric field. So if theta is 0, then you can put sine theta as 0 and therefore torque is equal to 0. So this is the first case. If the dipole is already aligned with the field, then the torque acting on it will be 0. Then the second case will be if theta is equal to 90 degree. If I take theta equal to 90 degree, then I will get PE sine 90. And sine 90, what is the value? It is 1. So I will get the formula for torque as P into E. And so this is the maximum value of torque. So when is the torque maximum on a dipole? So the torque will be maximum when it is placed, when the dipole is placed perpendicular to the field. When it is placed perpendicular to the field, maximum torque will act on it. And in between angles, say 30 degree, 40 degree, you can substitute. This is the formula P into E into sine theta. Accordingly, you will get the expression for torque. And the last thing is, what if sine theta or theta is 180 degree? So if you have placed a dipole in the opposite manner, a minus q charge here and plus q charge here, then if it is in 180 degree, then you can see that it becomes the minus value. But the in this case, the dipole, it will be unstable. So it will be in unstable condition if theta is 180 degree. And mostly it will not be able to place it in that particular position. So mostly you have to remember about the maximum value of torque and the zero value of torque. So in this way you have to remember the formula for torque, that is tau is equal to Pe sin theta. Then one more last thing is P into E into sin theta. Now torque is a vector quantity, electric field is also a vector quantity. So in terms of cross product also you can write torque is equal to P cross E. This also you have to remember this formula for torque, P cross E, cross product. Cross product of two vectors we have studied in class 11th. A cross B. A cross B is AB sin theta into n cap. Okay, so here sin theta is also there. P and E, these are also vectors. So we can write torque as P cross E. And the torque is acting in a plane which is perpendicular to both P and E, in which the dipole is lying and electric field is lying. And for finding the direction of cross product, which rule do we use? That also you must be remembering. It is the right hand thumb rule. So right hand thumb rule will give us the direction in which that torque will act, the cross product P cross E. So the final formula in terms of vectors, you can write torque as P cross E. I hope this formula and derivation is clear to you. Thank you.